Gateway on OpenShift facilitates deploying multiple container instances, or pods, within a Kubernetes cluster to allow for quick scaling and management of BlueCat Gateway in your Red Hat Enterprise Linux environment. Why OpenShift? Why would we want to install Gateway on Red Hat OpenShift as opposed to just running containers inside traditional Docker? One of the main reasons is central orchestration. With central orchestration, both developers and operations teams have access to pods running in OpenShift, making it easy for cross-team communication. These containers all run under the same management node, making it easy to orchestrate changes across all nodes simultaneously. My second point is speed and efficiency. With a simple YAML file with only 3 to 4 stanzas, you can get Gateway running in your Red Hat environment with as many nodes as you wish. Which brings me to my third point of scale and security. If at any time you wish to scale the number of Gateway pods up or down, it's as simple as either editing your YAML file and reloading the configuration, or you can click the up or down arrow beside the pod count in the UI. Now I'll just walk you through some customer use cases of why Red Hat OpenShift is a great tool for installing Gateway. So it allows for easy deployment of Gateway containers and containerized adaptive apps and plugins. So because our workflows are delivered inside containers, if there is the desire to run more than one workflow at the same time, or more than one instance of the same workflow, Red Hat OpenShift allows for running multiple instances of the same pod with the ability to just manage all of those pods with one management node. You have the ability to scale faster when needed. So if at any time you need to run more than one of the same node, it's as simple as just clicking the up arrow beside that node. There's no need to maintain a separate host machine for Docker. So traditionally, we need to provision a server with Docker installed so that we can pull the gateway image from key.io, in which case we would run the Docker command to get that container up and running. With Red Hat OpenShift, you can leverage OpenShift, which is already installed on Red Hat Enterprise Linux. Lastly, you can deploy changes faster with CI/CD, since, as I mentioned before, both developers and operations teams have access to the Red Hat OpenShift environment. So with that, let's jump right into the demo and configuration. First, let's just look at the environment that I'll be using. So for this demo, I'm not going to be running Red Hat Enterprise Linux. Instead, I'm going to be using something called code-ready containers. Code-ready containers is a self-contained hypervisor-ready Red Hat Enterprise Linux virtual machine, which acts as both the management node as well as the worker node. Through code-ready containers, I could run OpenShift with nearly all the same functionalities as if it were a production environment. The second requirement here is simply to have network access to BAM. And that's just so that once we have Gateway up and running, we can log in to Gateway. So let's shift over to our command line here. I've already initialized the code-ready containers server for the sake of the demo, just to save some time. So now I have access to the OpenShift command line interface. You can see here that we have all the OpenShift commands at our disposal. So first, let's take a look at the YAML file that we'll be using. So the first stanza here is for the pod itself, which is the gateway container. So we just have a name, we call it gateway. And then down here, we specify our environment variable for the BAM IP. And then we specify the image that we want to pull, and that's from key.io. And then down here for volume mounts, we're using a persistent volume for gateway data mapping to BlueCat_gateway within the container itself. The second stanza here is for the service node. So the service runs higher than the pod, contains the pod, and we're calling it gateway, and it's of the type cluster IP. And we're specifying the port inside the container to be 8,000. We don't need to specify a port mapping of 80 to 8,000 because by default, applications running on OpenShift will use port 80. Thirdly here, we have the route. The route is what the pod uses to be accessible by the browser. So we've called our route gateway because it's going to be used by our gateway pod. And the target port, once again, is 8,000. And then lastly, our fourth stanza here is for our persistent volume. Our persistent volume, like I showed above here, is called gateway data. And we're just specifying that it has 5 gigabytes of storage and it has read-write access so that Flask within the container can read the directory. And the reason we're using a persistent volume here is so that all nodes within the realm of management of our management node will have access to this persistent volume. Additionally, on container restarts, all of our data will not be lost and will be contained within our persistent volume. So without further ado, we will use the OpenShift apply, specify the file and the deploy file that we just took a look at. So as you can see, our pod called gateway was created, our service called gateway was created, and our route called gateway was created. Additionally, our persistent volume called gateway data, which I have mapped to my OPT/gateway data directory, has been created. So now if we want to see it from a browser, we need to get its hostname. So to do that, we'll just run OpenShift container gateway. And here, gateway, we're referencing the route that our pod is connected to. And here we have the name and our host/port, which is gateway-default. Default here is the project name, and the project is encompassing of both the port and the service, as well as the route and the persistent volume. So if I just take this, head over to a browser, you now see that I have a running instance of BlueCat Gateway on OpenShift. And I quickly just log in. And that concludes this demo of installing BlueCat Gateway in Red Hat OpenShift. Thank you for watching.